Okay, hi everyone. So vectors. Vectors is something that people do find difficult quite a lot at first because they seem quite abstract, but when you kind of get familiar with them, it will be okay. Trust me. Now, there's some new things to introduce here, and first off, I think we need to know the difference between what's called a general vector versus a position vector. Now, we need to establish what this I and j are as vectors. So what are I and j? Well, okay, the vector I denotes one unit along the x-axis, and the vector j denotes one unit along the y-axis. So notice what notation I'm using here. I'm using what's called a column vector, okay, or column matrix notation. So I would like you always to write your vectors in column form like this. All right, so this means one along the x axis, and this means none along the y-axis, right? So if I had a vector A, right, which it told me was 3i plus 4j, I would write that as 3, 4. If I had a vector B, which was just minus 5j, I would write that as 0i, be careful with that 0, and just minus 5, okay? So notice I never put i's or j's in there because j means move along the y and I means move 1 along the x, okay? So that's a general vector, but when we're talking about a position vector, which is what most of our work is going to be about, a position vector means relative to the origin. Okay, so look out for that word, and I'm going to keep saying it. If you see position vector, so if it says given A equals 5i plus 3j is a position vector, it means that we've got what we've got here. So 5 along, 3 up, this is my point here. So this is my vector A. You see my position vector A, right? Because it's 5 along that the x-axis plus 3 along the y. So position vector literally means it's going from the origin. A general vector means it could be applied anywhere. Because remember, if it just said A was some general vector, from our definition of what a vector was, a vector is just a magnitude of a direction, i.e. an instruction. So I could apply A at 3, like this, couldn't I? But the fact that A is a position vector means it has to start at the origin. Okay? I hope that makes sense. Now, unit vectors. What does a unit vector mean? You're going to use this notation quite a lot, and you're going to hear this word quite a lot. Unit vector means the vector has magnitude 1. Okay? Magnitude magnitude of 1. Okay, so length 1, that's what magnitude means. Magnitude means length. So can you see that I is a unit vector? Because, and so is j, because they only have one unit of length, right? And unit vector could be denoted as a hat. So if someone said a hat, that means it's a unit vector. Right, so look out for that notation. So that means that vector has length 1. But let's look at, say, magnitudes in general. So how would I find the magnitude of this vector A here, and how's that denoted? So the magnitude is denoted as these modulus signs, so these straight brackets either side. So remember A here, I write that in column form. I'll never write it as I and J. I really hate when people do that. The questions will give it to you in I and J, and then you straight away write it in this form. So the magnitude of 5, 3, it wants to know the distance, the length of A. So what's the length of this blue line here? Hopefully you're screaming out and going, well, it's got to be Pythagoras because that length is 5, that length is 3. So we're going to go square root of 5 squared plus 3 squared, right? So the magnitude has got to be 25 plus 9, square root of 36, so 6. Okay? Hopefully that's right. No, 25 plus 9 is 34. What am I doing? So square root of 34. Alright? So that's how you find the magnitude of a vector. And remember, vectors can be subtracted from each other. So if I move on to this slide now, let's do that a little bit more. So let's say I had two vectors, A, which was 2 and minus 1, and B, which was 3 and 0. Right? If I want to find the vector, the magnitude of A, like we say, magnitude of A then, you see it's just the top one squared plus the bottom one squared, so minus 1 squared. So this would be 4 plus 5, so root 5. Likewise, magnitude of B is just going to be square. You see, I don't have to draw the picture, you see? So 9 plus 0, because 3 squared plus 0. So 3, right? How do you find the magnitude of the vectors, or the vector between A and B, right? So what's the notation for that? So if I want to find A to B, so let's think about it. These are position vectors. These are position vectors, right? From the start of the question, it would say whether they are. So 2 minus 1, that's there. So this is A, right? And B is 3 along and 0 up. So here's B here, right? So the vector A to B, for instance, so this point here, A to B, right? So this is A to B, isn't it? How do I get A to B? Well, A to B, I need to go minus A plus B, don't I? So I go B minus A. So notice, every single time, last thing minus first thing. So if I had S to T, T minus S. If I had Z to B, B minus Z, right? So if I want to find the length of this red line here, the magnitude of it, I need to magnitude the whole thing. Okay? So B minus A. And how do I do B minus A? Well, you can see B is 3, 0, and A is 2 minus 1. So can you see that I would just top minus top, so 3 minus 2 is 1, and 0 minus minus 1 is 1. So you see top minus top, bottom minus bottom, the magnitude, and then I can do my normal stuff. So 1 squared plus 1 squared is square root 2. Okay? So when I want to find the magnitude between two vectors, I need to put them together first, then take the magnitude like I normally do. All right? Okay, cool. What about if we want to find out the angle between vectors and the axes? So let's say this time I want to, let's say I've got a position vector A, right, which is 3 and 2. So here's 3, here's 2, here's my cross, here's A, yeah? So if I want to find the angle between the vectors and the axis, so it might say, find the angle between A and J, right? So this is J, remember, the J axis, or the vector J. Remember the vector J is here, so it's just 1 across, isn't it? 1 up, sorry. How do I find this angle here, this theta, right? Well, hopefully you can see this is length 2 in green, and this is length 3. So hopefully you can see that theta must be the same as tan to the minus 1 of 3 divided by 2, right? It's just SOHCAHTOA, opposite, adjacent. Likewise, if I wanted to find the angle between A and I, so this is I here, so I'm looking for this alpha value, right? There's my triangle, there's 3, 2 up, but this time alpha is going to be tan to the minus 1 of 2 by 3, all right? Parallel vectors, how do I know if two vectors are parallel? Hopefully you know that they are a multiple of each other. So are multiple of each other in terms of, let's say A, like I say, is the position vector 3, 2, right? As we've done. If K was the vector 9 and 6, okay, can you see that this is just a multiple of 3, 2? So if I take out a factor of 3, if you've got a number on the outside, this is called a scalar because it scales the whole vector. It scales the x and the y. So when you have a number on the outside, it times the top and the bottom, right? So can you see that this is 3 lots of A? So K is parallel to A because it's a multiple of A. Let's get some examples on here then. So it says, look out for the worst position vector. That's my note to myself. It says, write these vectors in ij and k, ij in column form. So these vectors are not position vectors. It just wants to know how to describe that vector here. Okay? With magnitude, it's got magnitude 15. Remember, the length of the vector is its magnitude. Okay, and its angle between here is 45 degrees. So how would I find this vector in I and j form? Well, what I'm looking for is this length and this length here. So how many up is it and how many across is it? So again, we've got SOHCAHTOA. All right. So we're going to need to use tan. So tan 45 equals, let's find our, like, how many I we've got. Okay. So how many I do we have at the top here? So tan 45 is our opposite. Oh, sorry, not tan. We're going to need sine 45. Sorry, sine 45 opposite over hypotenuse, which is 15. So our opposite, our x value essentially, is going to be 15 times sine 45, which is 15 over root 2. Likewise, our adjacent, so this is our adjacent here, we're going to need cos 45. So adjacent over hypotenuse, 15 times that. So this is our y, so 15 cos 45 is going to be 15 over root 2 again. So the vector, let's call this vector, well, I've used that. Let's call this vector z. So the vector z is 15 over root 2 lots of I from here, plus 15 over root 2 lots of j. Remember to underline your vectors. If you don't have an underline, then it means it's not a vector. It means it's a number, which is not what you want. But remember, you always write your answer in column form. So there you go. Now you've got this second one, this part B. Okay, this has magnitude 8 and angle 20 degrees. So how are we going to find this vector? Well, it's the same again. We need to know how much its x element is and how much its y element is, right? So if we call this vector P, okay, so on the top, I could go straight into column form if I want, right? So to find that x, we need cos of 20 is x over the hypotenuse, which is 8. So this is 8 cos 20. Do you see? If I just times by the 8. And likewise here, we've got sine 20 is y over 8. So 8 sine 20. So P is going to equal approximately, I don't have a calculator on me, but if you sub that in, you'll get it. Sorry, don't have a calculator. I might have to go grab one if the next example needs one. Okay, let's try another one. Given that the point A has position vector, right, so that means it does start from the origin, and B has position vector 6, 3, right? So we can go straight into column form. So A, remember lowercase for vectors, uppercase for coordinates, right? So A is that, B is that, 6, 3, right? It says find the vector A to B. So if I just do that one more time, right? I don't even have to put it on an axis. Can you see? Because they all on the origin, A and B. If I just draw it abstractly, yeah? If I want to go from A to B, so A to B, this vector, I need to go minus A plus B. You see? So it's always last thing minus first thing. So A to B is B subtract A. Okay, and B is 6, 3. A is 4 minus 5. So remember, top take top, so that's 2. Bottom take bottom, so that's 3 minus 5 is 8. So there's our A to B. Okay. Part B, it says find the magnitude of A to B. So magnitude A to B is the top thing squared plus the bottom thing squared. So that's 4, what's that, 68, okay? And you can go from there. Again, look out for the word position vector. Doesn't say position vector, so we've just got some general triangle in space, which you can see here. Here's A to B and A to C, right? It says find the angle between A, B, and I. So that's a part A. So remember AB is 4 plus 3, 4i plus 3j, right? So even though it's not a position vector, I only care about this vector, right? So I can just put the vector here. So 4 across and 3 up. Okay? So there's my vector A to B. It wants to know the angle between that and I. Here's I. Right? So it wants this angle here. So what we're going to have to do, if this is 4 across and this is 3 up, you guessed it, alpha is going to be tan to the minus 1 of 3 by 4. Okay? And again, with a calculator, you'll be able to find that normally in degrees, yeah? And the angle between AC and I. So again, what I do is, here's my AC. So if I take AC, I can put it relative to the origin, because essentially what I'm doing is, I'm just doing this. I'm just saying this is I. Okay, find that angle. You see? This is I, find that angle. So I don't even have to do this coordinate system, but it just helps visualize things. So A to C is, as we can see, 6 minus 4 from here. So therefore 6 across, 4 down. And remember my angle, it asks for the angle between that. So it is underneath the x-axis, it is underneath I, but it's not asking for negative. So you could say below, you see? So I can say that beta, if I call this beta, must be tan to the minus 1 of 4 over 6, opposite over adjacent, and therefore you can say beta equals whatever that angle is below I. Okay? Now it says find the size of BAC in degrees to 1 decimal place. Hopefully, if you know hopefully you know what to do here, because BAC, that means A is sandwiched. We're looking for this angle here. We just need to add the two together, don't we? So angle BAC is going to be alpha plus beta, okay? Which you can work out for yourself. I'm conscious of time. Didn't want to be over 20 minutes. So let's get this going, this last one. It says the positions of 3 vertices of a parallelogram. This is so typical, okay? Are 4, 2, 3, 5, and 8, 6. I would, because it says position vector, definitely draw a picture. If you do not draw a picture, I don't want to talk to you, okay? Because you can't visualize anything without this diagram. So 5, so that's here, and we've got 8 along and 6 up, so that's even higher. So that's here, okay? We need to know the possible positions of the 4th vertex. So remember, we're trying to find a parallelogram. So here's my shape so far. So if I want a parallelogram, it's either going to have to be like this, isn't it? That's one variation. So let's start putting this stuff together. So I'm going to call this A, B, and C, right? So here's A, 3, 5 is here, B and C, okay? I'm trying to find D. Now, how do I find D? Well, hopefully, because you know that these things are position vectors, you know that's the vector B, that's the vector A, and that's the vector C, okay? I need this position D. How do I get it? How do I get, and this is the thing, how do I get from O to D? Well, hopefully you can see that, it's a parallelogram. And if it's a parallelogram, then this line here must be parallel to this line here. So can you see the position vector of D, because that's what it wants, the position vector of the fourth vertex, D. To get there, I need to go A first, plus, and now A to D. But A to D is parallel to B to C. You see? So I can apply the same vector. So A is 4, 2. Whoops. B to C is C take B, remember? So 8, 6. Take away B, which is 3, 5. So at the moment I've got 4, 2 plus 5, 1. So I've got 9, 3. Right, so that's one answer, but notice the question says find the possible position vectors. So it suggests that there's more than one, and I think that's probably because my diagram doesn't look too great. So if I put it on these points here, so my first option I did was this to this, wasn't it? That's one way I could do it, or interpret the parallelogram, but also notice it could be this way and this way. So therefore, if this is our vector A, oh sorry, this one was our vector B, wasn't it? This is our vector B, this is our vector A, this one was our vector C, then I need to actually consider this point as well, this one up here. So to get to there, this time D could be starting from the origin, go up B, that's cool, plus, and now this time it's the one parallel to A and C, because this is A, isn't it? This is C, this is B. Let me just double check that. Yeah, that's cool. Yeah, so actually this is the D I'm looking for. This reminds me of the Star Wars thing there. Yeah, these are not the droids you're looking for. So actually I need to add on A to C as well. Okay, so if you do that, you should get, well, let's just quickly do it because we're nearly out of time. So B was 3, 5. AC is the same as C take away A. So remember last thing minus first thing. So C was, what was C? 8, 6. And we know that A was 4, 2. So subtract 4, subtract 2. So I end up with 3, 5 plus 4 and 4. So that gives me 7 and 9. Okay, so the two possible positions of D are 7, 9 and 9, 3. Okay, I know it's a bit longer this video, but hopefully you learned quite a lot from that one.